Alright, this problem says a park has a triangular sandbox. Todd wants to create a smaller sandbox at his backyard having the same angles as the park sandbox. Drawings of both sandboxes are shown. What is the perimeter in feet of Todd's sandbox? So before we start answering the question, we're going to go back up and we're going to analyze the problem itself. Here, you'll see I've highlighted the same angles. When they tell us that Todd's sandbox is going to have the same angles as the park sandbox, it's just going to be smaller. That is telling us that Todd's sandbox and the park sandbox are similar, which means they are the same shape, but they're different sizes. So all of the corresponding angles are congruent, and all of the corresponding sides are going to be proportional. So remember, the perimeter is the distance around the outside of the figure. And that's what the problem is asking us to find. So you always want to identify, what is this question asking me? And here we want to find the perimeter of Todd's sandbox. So the perimeter is the distance around the outside of a figure. Right now we can't find the perimeter of Todd's sandbox, but we can find the perimeter of the park sandbox. So to find the perimeter of the park sandbox, you're going to take all three sides and add them together. So 14 feet plus 18 feet plus 20 feet tells us that the perimeter of the sandbox is 52 feet. We're going to use that measurement, the perimeter of the sandbox in the park, to set up a proportion. So remember, in similar figures, corresponding sides are proportional. So a proportion sets two ratios equal to each other. So here we can say that the perimeter of the park sandbox is going to be proportional to the perimeter of Todd's sandbox. We can also say that one side of the park sandbox, a side that we might know, would be proportional to its corresponding side in Todd's sandbox. So we're going to take our values that we know, we're going to substitute them into the proportion, and then we're going to solve for what we don't know. So we know that the perimeter of the park is 52, so we substitute 52 in for perimeter of park. The perimeter of Todd's sandbox is what we're trying to find, so we're going to represent it with a variable, which in this case, I used x. So we have 52 over x is equal to 20 over 8, because we know that one side of the park sandbox is 20 feet, and we know that the corresponding side of Todd's sandbox is 8 feet. So now that we have our proportion set up, we can use cross multiplication to solve it. So when we cross multiply here, you see we get 20 times x, because we're doing denominator of the first fraction times numerator of the second, is equal to 52 times 8. Numerator of the first ratio times denominator of our second ratio. So now we have an equation that we can just go through and solve using algebra. So 20 times x is 20x, and 52 times 8 is 416. Now we want to get x by itself. So remember, we need to use our inverse operations. The inverse of multiplying is dividing. So we divide both sides by 20, and then we get that x is 20.8 feet. So the perimeter of Todd's sandbox is 20.8 feet. Now you're going to try this question on your own. So a park has a triangular sandbox. Jane wants to create a larger sandbox that has the same angles as the park sandbox. Drawings of both sandboxes are shown. What is the perimeter of Jane's sandbox in feet? So you're going to go ahead and answer this question now.